Hello.
Yes, good afternoon. Hi.
How are you?
Yeah, doing well.
Welcome.
Yeah, I'm Dr. Gopinath, special show editor.
Nice to meet you, even virtually. Thank you very much for arranging the today's session.
Okay.
Congratulations, first of all, about the special issue.
Yeah, thank
I
you.
think it's a record, 27 papers.
Yeah, exactly.
Yes, Michael Watts mentioned it's an amazing effort. Thank you very much for
Yeah,
this.
welcome. Thank you.
And also a very interesting topic.
Yeah, thank
I see that we have 11 participants at the moment. Hopefully more people will join us.
Yeah,
But anyway, the session will be recorded and will be uploaded in the site of the SEGHlive,
okay, fine.
and from there it can be accessed. So I don't know, there are 7 talks, yes?
Yeah, six, 7, exactly, right. You're right.
Are all the speakers present? Do you know? Can
Yeah.
you see
Most
them?
probably they're supposed to join. Dr. Saswati Chakladar, are you available? Others, you can go for second speaker, Dr. M.S. Santosh. He's available on online.
Okay, so I don't know if you want to start.
Yeah, fine. Yeah, I want to say something about special issue. Yeah. Uh, Good afternoon to everyone. So I am honored to welcome you all to on the online presentation for the special issue titled Environmental Impact and Health Risk Assessment due to Coal Mining and Utilization in the Journal of Environmental Geochemistry and Health. As the special issue editor for this volume, it has been remarkable journey bringing together to diverse range of studies and understanding the highlight critical intersection between coal mining activities and their environmental impacts. So, apart from this, I would like to extend my heartfelt gratitude to the editor-in-chief, Dr. Michael Watt, and co-editor-chief, Dr. Diana Purchase, for giving me the opportunity serve as a guest editor for this special volume. Uh, and their support and guidance have been invaluable for and throughout this process. So I have to thank for that. Today, we have privileged to hearing from the distinguished authors from who has contributed this volume. Their research to cover wide topics from geochemical analysis of coal deposits and assessment in various point of view in environmental aspects so associated with coal mining activities. So each study provides crucial data and perspective that inform the future policies and practice aim to mitigating the adverse effect of coal mining activities and as well as utilization both. So also I wish to express my appreciation to the Society of Environmental Geochemistry and Health to organizing this event, especially for new president, so Professor Harindo Agrogi. So hope my pronunciation is correct. Yeah, so for organizing this event. So today we'll hear from some of the authors from various topics. Total already you said there is a total 7 topics. So we will go for hearing from these topics. So they will share about their findings and discuss their implication and engage in meaningful discussion that will further it will make our understanding to guide us future research as well as different new policies which that supposed to make in this scenario. So I hope this session will highlight and foster collaboration that can lead sustainable practice and improve the outcome of this entire session. So thank you for all of you joining today. So we can go for presentation. So, Professor, shall I call presenter to present?
Yes, so it is Alok Kumar.
Yeah, I think instead of in place of Dr. Alok, Dr. Saswati supposed to present. Ma'am, are you there? Yeah, okay, fine. We can go for second presentation. So I will call or inform. So we can go for second presentation, Dr. M.S. Santosh. So he is a scientist in Central Institute of Mining and Fuel Research, and he is head of the Department of Coal to Hydrogen New Research. Recently, he has initiated. So he is effectively working in these topics, and as well as not only coal to hydrogen, he is working in different material characterization which can be possible to make from the coal. The topic is natural subbituminous coal as a filler enhanced mechanical insulation flame retardant properties of fire polypropylene biocomposites. So I welcome Dr. Emma Santos to present this presentation.
Yeah, thank you very much. Am I audible?
Yeah.
Okay. Thank you very much, Dr. Gopinath, for facilitating this presentation. And thanks to all the editorial board members for having considered our manuscript positively and publishing it in this esteemed journal. I'll be sharing my screen and subsequently take it forward to make my presentation. Is my screen visible?
Yes. We can able to see it. Please
Okay.
go ahead.
So, very good afternoon. This is Santosh from Central Institute of Mining and Field Research. I'm working as a senior scientist, and we have been into the areas of coal and coal-derived materials, including composites and biomaterials, with a specific focus on hydrogen and carbon capture-related activities. But before going into the details, I would like to just introduce my topic that we have published in this journal, Natural Subbituminous Coal and its mechanical insulation flame retardant properties as a blend with coir and polypropylene biocomposites. So in this work, before going into the technical aspect of this work, my basic research area spans over hydrogen production, separation, storage, sensing, including that of carbon capture and graphene and other advanced materials typically derived from coal and coal-derived products. So primarily focusing on these material aspects, we have explored the opportunity to combine coal with biomass materials and try to produce composites that will eventually find applications. And we have also experimented them as false ceiling tiles and for interior applications within closed enclosure. So these materials have proven to be very promising, and based on which we are going to present some results out of this paper. So typically now across the globe, sustainability is a buzzword which comprises of a lot of energy efficient, cost effective and renewable sources dependent activities. And primarily basing on the bio-based materials, which is an important area where many agricultural wastes are coming into picture. And these agricultural wastes are unnecessarily thrown away or burnt out in order to cause a lot of pollution in the environment. But in order to stop their pollution, in order to stop the pollution that is coming out from burning these bio-waste materials or agricultural waste materials, we thought of utilizing these waste materials in a suitable manner by blending it with coal-based materials. But on the other hand, if you look at the coal as a material, coal is often explored or seen as a carbon emitting material because it is largely used in thermal power plants for producing electricity. So based on this carbon footprint that is produced by coal, it is always looked at as a very energy troublesome material, but not as a useful material or a product. But by blending coal with the biomass, we can convert the negative impacts of coal into a positive impact material and substantially utilize it for effective indoor applications as well, which most of the applications haven't been explored in the past. But there are certain challenges if we try to use a biomaterial. Biomaterials or biocomposite materials, as such, they are not good enough to meet the certain specifications and the associated properties that are required for some of the applications. But by blending them with organic, inorganic, or metallic additives, they can eventually gain the subsequent properties that will be helpful for various applications. And at the same time, blending these natural materials will eventually give us new options for material composites, and these material composites can be explored and extended further for various applications in diverse range of fields, ranging from interior decoration to false ceiling to energy applications and so on. So there are a lot of applications that we can focus upon. And why do we need to focus on these bio-based materials? Because these are eco-friendly materials and have been considered as sustainable. And most of these biocomposite materials or bio-based materials are most probably freely available, if not at a very low cost. And using their cost effectiveness that is currently available in the market, they can be transformed into useful materials that can subsequently be employed in various applications. But these bio-based materials being used as such may not be effective and efficient as a raw material itself. But if we convert these bio-based materials into suitable fibers, these fibers provide necessary strength and stiffness to the composite material and enhances the strength of the material, which will eventually be capable of bearing the necessary strengths to a much higher level. And these biocomposites also have certain challenges wherein, as I said, using additives for various applications will eventually make them improve in their performance and also be cost effective for various large scale applications. When we look at a larger perspective for application per se, it is important for us to understand how cost effective and economically beneficial are these materials in order to make them more sustainable and effectively utilize it on their larger scale. When we look at the coal as a material being used in combination with biomass and suitable binder material, we need to focus on three important applications or properties of coal, such as thermal insulation, flame resistance, and mechanical enhancement. Flame retardation is one important aspect that I would like to stress upon here because of the fact that coal being a thermally conductive material, it has a good amount of heat absorption ability, and because of its inherent property, it is being used in thermal power plants, which will eventually be used to produce power on a larger scale. But here, when we blend it with biomass materials, the flame resistance and thermal insulation properties significantly vary, and that's how the advantages of these materials can be very well utilized. When you look at the coal samples being used as a composites, we have specifically focused on some of the mechanical, acoustic, thermal insulation, and flame and water resistance properties of these materials. And specifically thermal insulation, we focus on the various applications of thermal insulation, followed by the flame retardancy that is being exhibited by coal-based composite materials, and the mechanical strength that it can offer to the biomass-based composites. Because eventually coal being a harder material, it has the ability to increase the strength of the biomass when blended with them with a suitable binder. So these three unique combinations come together in order to create a new material as such in the form of a composite, and at the same time offer new complementary properties in order to substantiate the deficiencies that were previously prevalent in these materials as an individual material, but rather when combined together, come up with a new format and a new material as such, trying to complement and supplement wherever the deficiencies and other suitable properties that are necessary in order to compensate some of the limitations associated with these materials. In terms of the morphology, when you look at the microscopic graphs, it clearly indicates that there are a bit of aggregation of these coal samples at some point of time. in the material in the figure A that you can see. And in figure B, there are sheet-like morphologies that are being visible, which are clustered together in one portion of the image. But the figure C and D clearly indicates that how these coal core composites can be visualized. And in figure D, you can clearly note that there are several pores that are available on the surface of these biomass materials. And these pores are the ones that provide suitable aeration ability when blended with coal, and also improve the strength, because these biomass materials are used in the form of fibers. These fibrous pores offer suitable strength to the biocomposite material when blended with coal. And at the same time, we also explored the tensile mechanical properties in terms of tensile strength and flexural strength. And as you can see from the two graphs, it is clearly evident that the tensile strength and the modulus of the composites were very good at ratio of 60:40, because of which there is suitable amount of coal coir and the blending of the binder material. But eventually, as you increase the percentage of the coir to 90%, the binder material composition drastically decreases. And because of this decrease in the binder material, there is no sufficient amount of the binder material for holding the coir materials together, and hence the mechanical strength of the material drastically decreases. Similar kind of properties are also available and evident in the flexural properties as well. And in this case as well, similar to the mechanical tensile strengths, these properties vary significantly. And because of the combinations of 60:40 and 90:10, as you can see, show the highest and the lowest properties in terms of strength and modulus. We also studied the thermal conductivity of these coal biomass composites. And as you can see from table 1, thermal conductivity initially of coal was much higher compared to the biomass and the composite materials. But at the same time, when they were blended with coal and coir as a biomass material, along with suitable polypropylene binder, there were different ratios of these mixtures that were blended together in terms of weight by weight ratio. And based on the variation from 30 to 0 to 30% in terms of coal variation, and keeping fixed keeping 20% as the fixed ratio for polypropylene, because we wanted to substantiate the suitable binder material that is sufficient enough for holding both the biomass and the coal together. And the percentage of coir was also varied from 50 to 80% in a cross combination, where 30-50 to 80-0 combination with polypropylene as the key binder material that holds together these materials. When you look at the flexural and tensile properties, the variations in terms of different compositions also clearly indicate that the 70-20-10 percentage of coir, polypropylene and coal shows a better strength in terms of flexural properties, and higher modulus also at the same time with 70-20-10. And on the other hand, in terms of the tensile properties, the highest strength was seen to be at 60-20-20 ratio, whereas the modulus was also seen to be at the same ratio with 209. So these things clearly indicate that any ratio between 60 to 70% of coir and 20 to 10% of coal composite combinations along with polypropylene would be a suitable material to maintain the substantial strength of the material, in order to make sure that these are utilized for suitable applications, for interior applications as such. So when you look at some of the other properties like sound absorption as well as water absorption efficiencies, there are clear indications that the 10% coal composition shows a much higher sound absorption coefficient, where it acts as a more soundproof material compared to its various other compositional percentages. Similarly, in terms of the flammability ratios, 0 to 30% variation of coal indicates that the V1 underwriters laboratories standards that is considered universally as one of the best ratings were evident in only coal as well as 10% of coal combination with biomass. Higher percentages do not fit into this particular rating because the variations will eventually lead to decrease in the flammability properties, and hence 10% property fits well into the compositional ratio that eventually meets the highest standard of underwriters laboratories standards as prescribed by and accepted by the international community. In terms of the water absorption, also we can clearly see that there is the 10% clearly indicates that it has a higher water absorption ability compared to the 30%, whereas coal as a individual material has the highest water absorption material property. But when you look at the blending of the materials, 10% eventually here plays a significant role compared to the 30%. So thank you so much for this wonderful opportunity. In terms of the overall composite materials, we can clearly say that there is a good opportunity for blending of these coal biomass composites. Here in this research article, we have only shown that coir has been used with coal and polypropylene as a binder, but there are opportunities for varying the biomass materials, not only with copper, we can use coffee husk, rice husk, or even tea waste or sugarcane bagasse. A lot of other biomaterial can be tested and in combination with coal and eventually explored for various other applications. So considering the overall activities, I would like to thank and place on record the support that we have received from various funding bodies and various scholarship and fellowship agencies that have offered us suitable support from time to time. And above all, my students and my group members who have been the strength of our group in carrying out a lot of research activities from time to time. Thank you so much for this wonderful opportunity. I hope I have completed my presentation in time. Thank you.
Thank you, Dr. Santosh, for a wonderful presentation. So, if any doubts, any queries, please you can ask Dr. Santosh. Anybody else?
If I can say something, it's not a question, but it is really an amazing work that has been presented by Dr. Santos. Coal has been demonized, and in our times, when people hear about coal, they always think of something bad for the environment, something that will cause harm to the environment. And this is the way to go forward, what you have just showed us. There are many alternative uses of coal, and this is how we should build our sustainable future. So thank you very much for this. I think for young people, your work is really inspiring. Thank you.
Thank you so much.
If anybody have any other doubts, anybody else, so please. Okay, thank you, Dr. Santosh, for wonderful presentation. So I will call next presentation Dr. Lal Singh as requested. He has some pre-commitments he want to present now. So I'm requesting him to present now. So his topic is evolution of plant species and air pollution tolerance and water remediation potential in proximity to the coal thermal power station implication for the smart green cities. So I request to Dr. Lal Singh to present his presentation.
Okay, thank you, sir. So presentation is visible, sir. Slide is visible, sir, all of you.
Yes, yes, yes. We can able to see it. So go with the presentation.
So slide is changing also.
Yeah, yeah.
Okay. So good afternoon, all of you. So we will discuss the evaluation of the plant species for the air pollution tolerance and phytoremediation potential in proximity to a coal thermal power station. Implication for the smart green cities. So problem because it is a byproduct of the coal. When it burn 400 to 800 degrees centigrade, then coal it contain various harmful substances including heavy metal, polycyclic aromatic hydrocarbon, and other toxic elements. So inappropriate management of fly ash and impact on significant environment challenges, as well as it can be ecosystem disturbances also. So improper disposal of fly ash can lead the contamination of soil, water, air, and causing harmful impact the ecosystem processes, and finally creating ill effect on the health also. The leaching of the contaminated fly ash and contaminated groundwater affecting drinking water also, and also it can create the problem to the aquatic environment. So also the surrounding environments can create the problem. So phytoremediation has emerged as a promising technique to mitigate environmental problems, as well as the that fly ash collected due to it's a eco-friendly approach and
Excuse me, Dr. Singh, there are some sound problems. Oh, is he disconnected?
Okay.
Maybe if you turn off your camera, it will help.
Dr. Lal Singh, please, video, please, can you off it so it can be better? We can able to listen. I think you are muted. You unmute it, you switch off. Yes. Then now you can share your slide and you can go ahead.
Oh, some interruption is coming.
Just please share your presentation, then continue.
Yes, and maybe if you stop video, if you press the button stop video, then it will help to hear you better.
What happened, Dr. Lal Singh? Okay, fine. So we can go for next presentation. You be ready, Dr. Lal Singh, in meantime. So now Dr. Saraswati is ready to present. So I'm requesting to present her presentation. She's basically a scientist. She's working in National Meteorological Laboratory, Jamshedpur, Jharkhand. So she's going to talk the topic of geochemical characteristics of Rajmahal coals in Dhulia, Northern Block, Eastern India, implication to the utilization and environment. So I request Dr. Saraswati to present here.
Yes, can you actually see me? Good afternoon, all of you.
Yes, yes.
Can
good
you
afternoon.
actually see me?
Yes, yes.
I think I'm audible, but I don't know, the video is not starting.
Yeah, no issue. You can share the presentation. You can continue.
Sure. All right. I think I'm good to go. The presentation is there.
Please share your presentation. We are not able to see it.
Is it? It's not there, right?
Yeah,
The
yeah.
sharing part is not quite apt. Yeah, there is probably some problem with the Zoom platform actually. Yeah, I think it's now good. Is it there?
Yeah. Now it's screen sharing, but not able to see still now.
Okay. But I think my video is not there, right?
Yeah, your video is not able to see it. That is not a
I don't
problem,
think
but still we are not able to see your presentation. Yeah, now we can able to see your presentation. Please go with presentation mode and start.
Shall I start with the presentation?
Yeah. Go ahead.
You're not able to see me, I guess, right?
Yeah. We can able to see your presentation. Go with presentation mode.
Okay. You are able to.
Yeah, now we can able to see your presentation.
All right. I'll just go with the presentation. And yeah, good afternoon, all of you. The topic of my presentation is the paper we published, which is Geochemical Characteristics of the Rajmahal Coals in Dhulia North Block, Eastern India, the implication to their utilization and environment. At the outset, I would like to say that this work is basically an exploration-based work, which is of utmost important at the moment for Indian subcontinent and specifically because we know that India has a good share of rare earth deposit, but we don't know exactly where they are. So the exploration part or the results from exploration work is still scanty in the Indian perspective. And keeping in mind that particular problem, we actually went ahead and did quite a bit of exploratory work on finding out the potential coal block during my tenure in NML, and as well as Neha Kumari and Azlan Mustafa was Dr. Sanchita Chakravarti in CSIR NML. So just a very brief introduction. Am I audible to everyone?
Yes, we can able to listen.
Am
But
I audible, Doctor?
yes. We can able to listen. Please go with presentation mode.
Sure. I am in the presentation mode. Can you see? Is the full screen I am sharing right now?
No, we cannot. And
We
the
cannot
slides are
Can you
not.
see the slides?
Yeah, we can able to see slide, but it's not in presentation mode.
And only the first slide, it is not changing.
Okay. Then I don't know what is there is some problem with the platform, I believe, because from here I can see everything, but
Now it is changing.
okay,
Now
then
we see
let's keep it.
the coal ash slide.
Okay. So I think I'll just keep it in the smaller window, because when I'm expanding, it's stopping to work.
Okay, go
Okay.
ahead.
Okay, I'll just keep it in the smaller, I mean this way. All right.
Okay.
Yes.
Yeah, so for the rare earth elements, just a small introduction, and I think the whole audience is aware of the different types of rare earth elements, the classification of it. I would like to keep it short and focused on the important bit, because just in lieu of time. So yttrium, neodymium, eurobium, thorium, dysprosium, and erbium, these are the ones which are considered critical rare earth elements with respect to its utilization, application, and so forth. So the question comes, why are they important? Why are rare earths important, and why is the whole world trying to get as many indigenous resources as we can? Because rare earth is in application in the field of magnets, as catalysts for polishing materials, in metallurgy, batteries, and ceramics and whatnot. So there is a huge application of rare earths. And considering that the way it is termed, rare earths, the deposits are very scanty. It's not that we get a lot from one deposit. So when we get substantial quantity of rare earths, that's what makes it extremely important. And another factor is to get it pure. So now that is probably the biggest challenge in as far as whatever work we have done in India. What we could see is that most of the rare earth elements comes in combination with other rare earth elements. For example, lanthanum, cerium, neodymium, they most of the times they coexist, because these rare earth elements, they do not differ in much of the chemical or physical properties for sure not, but even not chemically. So it is very difficult to get it in pure form. So now the next thing is to look at the source, in particular what we were interested in, which is coal ash. Now, why coal ash? Coal related byproducts such as coal fly ash, coal tailings, and coal mine drainage has been identified as potential source of REs because of the enrichment. In India, coal and coal byproducts is escalating just because the thermal power plants are, the power requirement is increasing, the thermal power plants are increasing. I mean, like the more the demand for it, and the more we want to give the optimum supply. So the production of coal ash is also escalating quite a bit. Now, that is why when it is generated in huge quantities from thermal power plants as a byproduct, we would like to utilize it as much as possible, because they are ultimately going into the coal ash pond, but we would like to get something valuable out of it. And once it is converted in the ash form, it becomes even more enriched in rare earth elements, not as when it's a coal. When it is in the ash form, it is rich in minerals, and depending on where the coal has been extracted from, it is rich in rare earth elements. Now, the question is, which I already started with during my first slide in the presentation, is that do we know where the rare earths are? Do we have enough data based on the exploration work of rare earth enriched coal blocks? And the answer is still not as many. There are quite a few papers which I have cited, and I think we have some of the scientists in the audience as well. We have done some of the very thorough examination of the geochemical characteristics of Indian Gondwana coals from various basins, and but still the knowledge of the distribution of REs, like which area is rich in what, is there a selective enrichment of any rare earth, such informations are still very scanty. So I have just picked up the map of India showing that kind of the abundance of the major minerals, which are rare earth enriched minerals like monazite, xenotime, and bastnasite. As you can see, bastnasite is primarily in the I think the West Bengal region. You can see Tamil Nadu and Orissa, Kerala, they are all rich with monazite, and Chhattisgarh, Jharkhand, they are primarily enriched with xenotime. So moving on to Rajmahal coalfield, which is our study area in the northeast of Damodar Basin, the organic characterization of such coals have been performed already. Like since there are papers in 2020, 2021, they have been performed. So what the previous prior studies were focused at, they were focused at knowing how did these these coals originate from? What are the organic transformations which happened in the coal? But what we thought was, why not look into the inorganic geochemicals? Why not do the inorganic geochemical studies on these coals? Because unless we do that, we don't know about the RE enrichment, and even we don't know the paleo-environmental conditions and how did the origin, what kind of origin it is of the coal deposits. And then that will only help us to make a perfect utilization of these deposits in terms of, is it just rare earth enriched, or is it there are some good valuable trace elements in there? Can we utilize it? Are those harmful for us? And numerous questions we had in our mind before trying on this particular study, before selecting this study area. So what are the results? Now I'll go on for the results. What we found out was that this particular coal block, we did a thorough in-depth analysis of at least 15 samples we collected, varying in depth, and we found out that it consisted primarily of major oxides of silicon dioxide, aluminum oxide, iron oxide, which totally accounted for 94% of the total ash composition. If you look at the mineralogical side of it, it was predominantly quartz, as you can understand, is SiO2, clay-rich minerals like montmorillonite, kaolinite, and pyrite, of course, some of the iron sulfide. So there is a certain percentage of sulfur which I have noted, which I have quoted in the next sentence. The average sulfur ranged from 0.5 to 3.8%. Some of the depths had very high concentration of sulfur. High carbon content from 71 to 79%, average was around 76%, and hydrogen content usually is around 3.5 to 4, so here it was 3.5 to 6%. Compared with the average world coal ash, the total rare earth content in the analyzed samples ranged from 341 to some of the lowest concentrations to almost 810 ppm, which is substantially higher than the world coal ash. I'll come to the graph later on. And if you look at the major oxide ratio, which is suppose the aluminum oxide by titanium oxide, it was less than 20, which indicated that the parent rock may be intermediate igneous in origin. So these are the questions we had in terms of the geological understanding of the coal's origin. And the major and the trace elements indicated the Dhulia knot block. The coals from this Dhulia knot block were deposited in the basin during hot and relatively humid paleoclimate and under oxic depositional conditions. So this was all the geological understanding and the calculations. It was done by Alok, who is the primary author for this paper. And we all together did the in-depth analysis of the mineralogical compositions as well as the elemental compositions. So moving on to some of the graphs which we have supporting our observation regarding the origin of the coal deposits. The distribution of aluminum oxide and titanium oxide, which is often used to know the parent rock genesis, as the concentrations do not change significantly during diagenesis and weathering of the parent rock. What we found in our case was that since the ratio, which I already mentioned, was less than 20, it indicated that it indicated an intermediate igneous parent rock being the origin. Furthermore, the plot of TiO2 versus aluminum oxide and zircon supports the presence of intermediate source rock. And titanium was found to be extensively coupled with clay lattices, which we also found, which was supported by XRD analysis as well, which I haven't shown in the presentation. But titanium primarily exists as anatase or rutile. So we found that it was extensively coupled with clay lattices and has a low input of detrital mineral matter during the formation of the coal deposits of this particular area. So as you can see in the graph, I have shown that these are the 15 depths which we analyze, which lies in the intermediate source. As you can see for both the plots, these regions, the calculations for these regions lie in the intermediate source. Now coming to the rarer distribution, what we found that the coal block of Dhulia knot was enriched with light rare earth elements. Heavy rare earth elements are usually very much in lower quantity in the Indian subcontinent. We have done distribution studies for several other areas, and we found that has been the consistent observation. And even for Dhulia North, it was the same, that it is enriched in lighter rare earth elements. Now, when we look at the quantification of rare earth elements, as you can see from the first graph, the orange one depicts the world average for coal ash, and the blue one is from this particular coal block. So it is significantly higher, the world average. And in particular, I would like to point at some of the important ones such as cerium, lanthanum, neodymium, and yttrium and scandium. These five rare earth elements are actually important. We have to understand that these elements are quite in abundance in Indian subcontinent, unlike the ones which could be critical, but they are not as abundant. For example, you can see erbium, the yttrium, these are not there as much as you can find the quantity, as you can see the quantity of lanthanum or cerium or neodymium for that matter. When you look at the outlook coefficient, the calculation, typically if the value is close to 1, that tells us that that particular depth is rare earth enriched. So in this case, what we saw that most of the depths had the calculation the outlook coefficient from 0.7 to 1.6 for all the samples which we studied, and hence we concluded that these coal ash samples are promising source of rare earth elements, and it is definitely worthy to pursue in terms of exploration or extraction of rare earth elements, which is anyway the next step after the exploration studies. Moving on to the trace elements, these are equally important like rare earth elements, because we need to know what harmful trace elements are in the coal block, as well as what can be economically explorable. So in this case, what we found that in these samples, zirconium, barium, chromium, manganese, molybdenum were on an average they were on the higher side. So that is like more than 300 ppm. This was followed by nickel and vanadium, which was more than 100 ppm in concentration, while the other elements like copper, cobalt, zinc, etc., were less than 100 ppm. So they were not significantly contributing in the concentration of the 6 to 7% which we saw, apart from the major elements. So zirconium, as you can understand, the presence of zirconium tells us why this particular coal block is Re enriched, because zircon is one of the most prominent hosts of rare earth elements. So that is ZrSiO4. So that's zircon being the main element is zirconium, and that is already in abundance in this coal block, which is more than 300 ppm. And the two graphs which I have shown, these are again for we plotted because we wanted to know the conditions under which this coal block was formed, so that we can again exploit it in a very efficient manner. So there are certain things to know, which is vanadium is more abundant in the anoxic marine conditions compared to nickel. And as you can see, the ratio of vanadium to nickel was less than 1, which implied that primarily these coal samples were formed under oxic depositional conditions. And further, we did some plots regarding nickel and using nickel and vanadium concentrations. And from those also, we concluded that the paleoredox conditions prevailing during sedimentations, and again, these are indicating that these coal blocks are formed under oxic conditions. This was the unanimous conclusion. Looking at the Sealer diagram, this is again done to understand the carbon and hydrogen percentage. When we plot it, we can gain an understanding onto what kind of coal is this, what kind of coal samples are these. Are these suitable for metallurgical coke, or could they give gasification products, or could they give high strength char, or are they more suitable for liquid fuels, which can be obtained by pyrolysis or hydrogenation or solvolysis. So from the plot, what we could understand is that the utilization potential of these coals, where it was concluded that they were primarily suitable for gasification. So these are the regions which has been color coded here. So just for you to understand, I think I made a mistake here because the dark gray, this is the area. I'm sorry, this is just for the understanding of for you to, if the font size is too small, but this is the lighter gray is the gasification one. And the darker gray, probably this is the place which is the coexistence of the two things, like the liquid fuels as well as the high strength char. This is the region. Sorry, this is not the right arrow. This is for the gasification part. So these coal samples were suitable more for the gasification. And the last observation is the Van Crevelen diagram. This is again to know what kind of coal is it, which goes hand in hand with the previous graph. These coal samples from all the depths, as you can see, it lies in the type 3, which is basically the low ratio of hydrogen over carbon and oxygen over carbon. So this is the y-axis is H over C, and this is the oxygen over carbon. This indicates the gas prone type 3 kerogen, while the higher ratios, as you can see, type 1 and type 2, these are the oil prone coal samples. So in this case, what we understood is that these particular coal samples were gas prone coal samples, and hence they were suitable for gasification. So these were the primary findings from the analysis, from the exploration based analysis, what we did. And here is the conclusion. The negative correlation between aluminum oxide and silicon dioxide denoted that silica is mostly present in the glass phase instead of clay minerals. So either it's the glassy SiO2 phase, or it's like in combination with aluminum as in clay minerals. So here it is primarily glass phase. As I already mentioned, the average value of total REs in the resultant coal ash samples was higher than that of the world average coal ash. And these coal ash samples, and hence the coal samples, are quite suitable for RE exploration based on their high outlook coefficient range. And as far as the origin is concerned, these are originating from sedimentary rocks accompanied by felsic influences. And also, finally, we concluded that the very low slagging tendency of Rajmahal coal entails its suitability for utilization during combustion process. With this, I would like to conclude my presentation. And lastly, I couldn't find the photograph of Sneha, but she's the second author in the paper who primarily contributed in doing the ICP-MS analysis of these samples. And here it's Alok and Dr. Sanchita Chakravarti, and that's myself. So thanks very much for your kind attention. And if there are any questions, I would be happy to furnish.
Thank you, Dr. Saraswati. So if any doubts, anybody else, so please ask Dr. Saraswati. Seems to be there is no questions from audience. So thank you, Dr. Saraswati. That starts with RE exploration and suitability of coal for gasification. So
Yes.
both it is very important topic. So the perspective of Indian coal industry. So
Yes.
because we are totally almost 70 to 80% critical elements we are rely upon the imports. So as well as government of India also encouraging to go for RE exploration. So
Yes.
yeah, it's
And
very
I think that is also increasing. With time, we are increasing because we don't want to be dependent on China for that. So
exactly.
we are increasing our exploration studies and I think you yourself have contributed quite significantly for such work as well.
Thank you.
So,
Yeah.
so have you? So just maybe just out of curiosity, have you explored the trace elements as well, or is it
Uh,
rarer? And
yeah, we are about to start a work. Recently, I got one mission mode project, it's 2 crore. So we are about to start. I think due to the election process, we didn't receive fund, and most probably this month end, I'm going to receive fund. So and we are going to start as a pan India basis for RE
perfect,
exploration.
perfect. So is there any particular? So you are It's an exploration based work, or is it a
Yeah, it is
quantification?
exploration based. When recently Ministry of Mines has declared around 30 critical elements, which is
Okay.
essential. So currently,
Okay.
so I'm targeting for that particular 30 minerals.
Perfect. Perfect. All the best for that.
Yeah, thank you, thank you, thank
Yeah.
you,
Thank you very much, Dr. Gopinath.
thank you, thank you, thank you,
Yeah.
thank you.
Thanks.
So seems to be there is no questions from audience, so we can go for next presentation. So next presentation, Dr. Ransifal Matthews.
Thank
He's a senior scientist. He's working in Birbal Sahni Institute of Paleoscience, Lucknow, India. So his topic is lower Permian Gondwana sequences, Rajara, coalfield called Dalton Kach coalfield, Damodar Basin, India, floristic and geochemical records and their implications on marine aggression and erosional environment. So I requested Dr. Ransifal Matthew. So please go ahead with the presentation. Please unmute it.
Yeah, can you hear me now?
Yeah, we can.
Thank you, Dr. Gopinath and Dr. Adrian also.
Yeah, thank you.
Giving us this opportunity to present over here. I'm just sharing my PPT.
Yeah, sure.
And I'm stopping my video also.
Yeah.
Is it visible now?
Yeah, we can able to see.
Yeah. Thanks again. And thanks for the editors also for the approval of manuscript in this particular journal. So we are, this is a study on Rajhara coalfield in Damodar Basin of India, particularly the implications of floristic and geochemical records and the implications of marine incursion and deposition environment. So a little bit different from that of the previous presentation, which mainly focused on the elemental composition as well as the utilization aspect. In this, we will be talking a little bit about the paleo environment and its implications also. So this is a study which done by a group of scientists from Birbal Sahni Institute of Paleosciences. Dr. Shankar Suresh Kumar Pillai was the lead author. Manoj MC, Ransifal Matthews, Srikanta Murthy, Mrityunjay Sahu, Anju Saxena, Anupam Sharma, Sanghamrita Pradhan and Suraj Kumar were the co-authors, and the work has been done in the Birbal Sahni Institute of Paleosciences, Lucknow only. So coming to the introduction, as you all know, India is a fragmented part of the United Gondwana land comprising India and most of the southern hemisphere continents present day. So in the figure itself, we can see that. Yeah, all the continents, southern hemisphere continents, present-day continents, together form the actual Gondwana land. And considering the Indian continent, the Indian peninsular India, these basins, actually, these Gondwana coal-bearing basins are being deposited in various isolated basins or paleo rift valleys. And present day, we can find these are these sedimentation in the rift valleys scattered all over the peninsular India. And these deposits are very important for us because it serves as a major support for the economy of the country because of the huge amount of coal resources, as well as for researchers like us. It also helps us, it gives us an immense opportunity to do the study of particularly paleo environment, how the coal was formed, the climatic implications, many aspects related to this. So in that way, these deposits also help us in a lot way manner. And now you can see the Gondwana, considering the Gondwana deposits, most of these deposits actually formed from Glossopteris, which is the major flora during the lower Permian. In this figure, you can see that it was distributed all along throughout the continents, almost all the continents. These are the paleolatitudinal distribution of Glossopteris flora. So this flora basically formed a huge forest, large forest environment during that particular time, paleo environment. And during Permian, Permian Gondwana sediments from Indian basins are considered to be continental non-marine deposits based on sedimentological and floristical aspects. So this flora, this Glossopteris dominant flora, flourished in this particular area and was considered to be formed in mostly in non-marine conditions, that is fluvio-lacustrine as well as fluvial conditions. That was a consideration which was previously people used to thought, but later on there were some patchy records of marine influences also, but people were not sure from where it has come, where the marine influences came from into these basins, because these basins are present towards the central part of the India. So from where this marine influence came into this basin was a question. So different theories or hypotheses were made, like one hypothesis of two-arm theory, which suggests, or two-arm hypothesis which suggests that it came from the one arm of Tethys came from the east and one arm from the west. So two arm of Tethys came towards the central India, which caused some sort of some influence in this formations. However, some people also say that there was only one incursion, but there were many hypotheses. There were some people say multiple pathways also. There were many publications regarding this, but almost all the patchy reports. Considering our study, which was basically done on Damodar Basin, from where it came was one major question, and what are the wider implications of it also. So one of the objective for study is to use the geochemical and organic and inorganic proxies to delineate Permian deposition environment and possible marine incursion from Rajara, Kolari, Darpanganj, Coalfield, Damodar Basin, and to understand the wider implications. To study the megafloral and paleontological composition to derive their biostratigraphy, highlighting the paleo-environmental conditions. So this is the Rajara area, and this shows the lithological units which were present in the mine section. It was a open cast mine from where we collected the samples. So there's a sandy shale at the bottom, about which we sandstone at the bottom, over which we have sandy shale and poly shale units, from where we are getting impressions, leaf impressions, and all, and some penomorphs also. So these are the sample numbers which we've taken for this particular study. Now, this is a study which we have done based on multi-proxy analysis, which include geochemical analysis as well as the microscopic and megascopic parameters. So consider the geochemical aspect, we have done both organic and inorganic proxies. So organic proxy is one of the major aspect, that is the study of biomarkers. The biomarkers are very specific compounds which give interpretation or a very good idea about the paleo environment, the floral composition, and many other related aspects. However, the study in Rajara, our samples which only showed a few compounds, that is in the distribution, if you see, only we are getting a few compounds, that is from 15 to 22 or 23, 24, that's it. So these are called short chain analkanes, whereas a similar sample from a basin, Rajmahal Basin, that is from the Lalmatia coal mine, shows a short chain alkane as well as the long chain alkanes. There's a huge difference between this, because if long chain alkanes are present, that is suggesting input of higher plant into this samples. Whereas in Rajara samples, even if there is a what we are dealing with is a colloidal sample, there is no long chain alkane, suggesting that there is some sort of distortion happened to this particular chromatogram or the distribution. Similarly, we also studied the terpenoids. Terpenoids also showing no peak, suggesting that there's some sort of distortion happened to the original composition. So there's a study by Patra et al. 2018. In that study, we can see that this is the terpenoid composition of an immature coal, and whereas what happens during high thermal maturity or high maturity, it happens that it used to get all the compounds are getting removed from this. So this is a similar case what we are having in this sample also. What happens is that the terpenoids and all other compounds were removed from this sample because of the high thermal maturity induced by dikes. Actually, we gone through some literatures and we found that the area was affected by dikes. So most probably because of the presence of dikes, this compounds get obliterated from this particular samples. However, we studied the pristine and phytane ratios also, which suggested, which also again suggested that there was some sort of distortion in the sample. Now, coming to the palenomorphs, again, you can see the palenomorphs recorded are shown over here, and the palenomorphs recorded were grayish black, and the rest were brownish in color. This dark to grayish hue reflects thermal diagenesis, probably related to the intrusion of dikes in the surrounding area. Again, it supports the presence of dikes in that particular area. So the present Pelno assemblage, which is suggesting that it falls in the Sherungri Polynitis Barakarensis zone of Tiwari and Tripathi of Rani 1992, which suggesting that the age of these deposits as Artin skin, that is 290 to 283 million year old. That is the age of these deposits. Now, the palynology mainly consists of chordatates, coniferals, and glossopteridales. The overall composition was very similar to the nearby mines also. So here, this is the megaspores, which we have recorded from the colliery. Now, coming to the elemental composition, which is very similar to that of Dr. Shashwati was showing. So we also studied the elemental composition based on trace elements and major and rare elements. So the coefficient of concentration coefficient is shown over here, which suggests that there's some abundance in the significant enrichment in some of the trace elements in this, like nickel, carbon, chromium, rubidium, thorium, etc. And the oxides are also very much enriched in these samples. We also calculated the indices such as the chemical index of alteration, Plagiocase index of alteration, chemical index of weathering index of Parker, etc. And we plotted these diagrams, which again suggesting that these samples are plotting at a strong weathering zone. So that means that these samples were, during the formation of these particular samples, there was strong weathering was there, suggesting warm and humid climatic condition during the formation of these deposits. And again, these ratios will plotted, and you can see that most of the samples suggesting that is formed in a warm and humid climatic condition, but one particular sample, that is RDB7, which is totally different from that of other samples, suggesting a variation in the during the deposition moment. So again, some other plots were also plotted based on the elemental ratios like thorium and uranium, strontium and strontium and barium, etc., suggesting that most of the samples were formed in a brackish water environment. And one particular sample number 7, which is formed in a saline environment. That is which we are getting over here also. The RDB7 sample is showing a different environment, which most probably because of the samples are formed in a marine influence environment, which is again supported by other graphs also. So a similar study which we have done in the Lalmatia coal deposit, that is in the Rajmahal area, which also had a similar data, but there the sample were mostly formed in the brackish water environment. But here we are getting saline environment also. So that is definitely suggesting that there is a marine influence into these deposits during the formation of these deposits. Now, from where this marine influence came. So that was the question. So we studied the Rajmahal area. We are getting the marine influence over here, and also now we are getting in the Rajara area also. So what we believe that this marine influence came from this side only. That is in this figure. This is the Kingaon region that is presently in the present day Sikkim. From this area, the Tethys, actually one branch of Tethys came inside till Rajara. So this is the pathway of marine incursion into this particular area. We also studied the megafossil assemblage, and megafossil assemblage primarily comprises of impressions of leaves and stems, which were studied using morphological characters. The dominance of narrow-meshed, medium-sized glossopteris leaves with an entire margin indicates a temperate to warm climate with high humidity, again, which is supporting that elemental data also. The diversity of megaflora during the deposition, along with the presence of different megaspores in the assemblage, shows a dense forest with swampy conditions. The present megaflora assemblage show a close similarity with the flora of other coalfields of Baraka Formation from Damodar Basin, Mahanadi Basin, Rajmahal Basin, Satpura Basin, Son Basin, and Godavari Basin. So what are the conclusions? The altered analkane distribution and complete absence of open suggests that the thermal alteration of the sediments probably due to the proximity of dikes in the coalfield. The L2O3 TiO2 ratio suggests intermediate rocks as a probable source of the Rajara colliery sequence, except RBD7, which suggests mafic igneous source. The RE distribution is nearly uniform in the shaly sandstone and sandy shale and coaly shale samples, whereas the enriched LRE and high LRE by HRE ratios, which depleted European anomaly, especially in the shaly sandstone, confirm a felsic source. The high chemical index of alteration and trajectories in index of alteration values imply a steady state of weathering and a high degree of alteration of source rocks, possibly under a warm, humid climate condition. The high thorium by uranium values and strontium by barium values suggest that mostly formed in a brackish water area, and in SAM RDB7 there is a an influence of seawater has been delineated. Diverse floral assemblage include pteridophytes and gymnosperms along with pelnamoths. Is indicative of luxuriant vegetation during the deposition of lower Barakar formation, which generated thick coal seams in the larger colliery. The megaspores indicate the presence of lycopsids. An early Permian age, Artinskian age, is assigned to these deposits. And the study also reveals well-diversified glossopteris flora, included glossopteridae, chordatae, sequestales, along with the lycopsids in the presence of and in the present assemblage, represent a dense forest with a swampy vegetation having warm and humid climatic condition prevailed during the formation of this sequence. So what is the present day implication or broader implication? What you can say? All these deposits were formed, as you all know, from different types of plant groups in Paleozoic, even in Mesozoic and Cenozoic also. So what happens is that these plants, once it dies, it will be deposited, and these deposits will go through purification, qualification activity, it will form macerals, and along with that macerals, we also get mineral matter also. So usually in coals, some particular macerals which I want to focus on, that is mineral matter, which I want to focus on, that is sulfur. In Indian coal, sulfur content is approximately around 0.6%, whereas at some part of the northern part of India, like in northeastern coals, the sulfur content is very high. Why? Because these coals are formed by the influence during the formation. There was a marine influence during this deposit. So sulfur content is always high if there is a marine influence during the formation of this particular coal. And sulfur content, if the sulfur is more, it will affect the utilization aspects, and it will also cause environmental degradation also. So this is very important to understand. If the sulfur, how much sulfur is present in the coal before the coal can be utilized for various utilization activities, as well as the to understand the environmental degradation due to the different kind of processes which we are doing on coal. So before doing the exploration of these coals and all, if we know about the environment, which kind of environment it is formed, it will help us a lot before planning. And these are a very important aspect for better understanding of the utilization aspects, as well as to avoid the environmental degradation which happens due to the utilization of coal. So thank you so much. This is just I want to present.
Thank you, Dr. Principal Matthew.
Thank you so much.
Yeah, if any questions and anybody want to ask, please ask.
Can I ask something?
Yes, please.
Yes. Can you tell us, for the international audience, what is the age, the geological age of the Indian coal fields in general?
Most of the coals are basically lower Permian, Gondwana coals, what I'm saying, lower Permian, but we also have Cenozoic coal deposits. We are also having it is distributed all around, scattered all around the country, because we can get Cenozoic lignites, particularly in southern parts and western parts of the country. But in the peninsular India and towards northern and northeastern part, you are getting Gondwana coals. That is a lower Permian age.
Okay, so you have a long range of ages, I guess.
Yes.
Thank you.
Thank you.
Excellent research.
Anybody else? Any questions from others? Thank you, Dr. Ransipal Matthews, for your wonderful and detailed presentation about depositional environment in reference to Rajagara coalfield. And thank you.
Thank you, sir. Thank you so much.
Thank you. So next presentation, Mr. Prasanjit Chakravarti. So he's a research scholar. He's working in Central Institute of Mining and Fuel Research. So his topic is trace element contamination in soil surrounding the open cast coal mines area, and it refers to Raniganj coalfield in India. So I request Mr. Prasanjit to start the presentation.
Am I visible?
Yes.
Yes.
Very well,
Okay.
Prasanjit. Yes, unmuted. So seems to be you're muted. Prasanjit. Prasanjit, unmute it. It seems to be you're muted. Yeah.
So, okay, sir.
Yeah. Now you share a presentation, you start. Yeah, go
Good
ahead.
afternoon, everybody. Yes, good afternoon, everybody. Myself, Prasenjit Chakravarti. I'm a DST inspired commercial research scholar, and I would like to thank you to the editor-in-chief of the journal in Environment, Geochemistry and Health, and the editors of the special EGAH special issue, Environmental Impact and Health Risk Assessment due to Coal Mining and Utilization. So I would like to present my published article, which is Trace Element Contamination in Soil Surrounding the Open Cast Coal Mines of Eastern Raniganj Basins, India. And the co-authors are Prasenjit, myself, David A. Wood, Siddharth Singh, who is my supervisor, and Bodhisattva Hajra, who is my co-supervisor. So let's start with a basic introduction of the coal mining and related activities. As we all know that coal mining produces trace elements or heavy metals, which can impact which can cause soil pollution if it exceeds the geochemical background value. And it is very well known from the Geological Survey of India that majority of the Indian coal reserves, which is approximately 56%, occurs within the 300 meters of depth, and that's why it is very easily accessible for open cast mining. And to get 1 ton of coal, we need to remove 4 to 7 tons of overburden rocks, and that requires 4 hectares of land to dispose. And open cast coal mining also produces 4 to 11 times of more overburden rocks as compared to underground mining. Even in the picture A, it can be seen that on the right hand side, there is a layer of topsoil that has to be removed to get the sedimentary rocks on the left hand side, as shown in that red arrow marks, and then we can we can get the access to the coal seams. In the figure B, we can see that the open transportation of overburden as well as the coal, and this is and in the image C, it can be seen that this is a Damodar river, and the coal dust can be seen very easily. And in the figure D, it can be seen that it's an abandoned mine, and we can see that few fumes are generating from there. That is because of the spontaneous heating of coal on shell. So various studies have been conducted in different coal fields of India. For example, Raj et al. 2019, Master et al. 2015, Pandey et al. 2017 and 15, and they have shown that lead, zinc, cobalt, nickel, chromium, arsenic, these were the major pollutants which causing soil contamination. Similar international studies have also shown that lead, chromium, zinc, copper, nickel, these are the few common trace elements which are causing the soil pollution in the areas proximate to coal mines. That's why the objective of this study is to spatially distribute the trace element in the study area, so that we can highlight the hotspot areas of which areas are basically polluted. And then we have tried to statistically correlate it with the and to assess the origin of those pollutants. This will help in formulate the strategy for soil remediation. So a brief introduction of the study area, that the eastern region of the Raniganj Basin, the study involves Pandaveshwar, Sonpur Bazari, Bhakola areas, which are very proximate to open cast coal mines, and it falls in the Bardhaman district of West Bengal, India. And the topography is generally plain, but it comes with a gentle undulating, having some small valley and ridges, and it is surrounded by major industrial cities. For example, Asansol and Durgapur, they are very close, and they have steel and thermal power plants. They are basically 20 kilometers from the study area, and mean temperature varies from 42 to 6 degrees centigrade with a prevailing wind direction northwest to southeast. This is the map of the study area, where the red dots are the sample locations, yellow highlighted parts are the urban or village areas or settlements, the brown highlighted colors are the major coal mining activities occurring there, the black highlighted areas are the coal mining operations which are undergoing. Orange color activities, we can see that they are the brick industries, and the green color are the agricultural areas. So the methodology has been derived that surface soil sample of depth 0 to 15 centimeter has been collected from different locations as shown in the map. And then we went for the geochemical analysis, that is pH, TOC, trace elements, and soil texture. and then we digested those soil samples using the microwave digester and analyzed using the ICP spectrophotometry. Then those data, those elemental concentration has been used to prepare special distribution maps using ArcGIS, and then we went for the environmental pollution indices, for example IGO, enrichment factor, contamination factor, ecological risk factor, and pollution load indexes. Then to determine the sources, we employed geostatistical analysis, for example peer correlation, principal component, to understand the source of origin of those trace elements. So let's come to the results part. The pH is varied from strongly acidic to mild alkaline, slightly alkaline, and the TOC varied from 0.2 to 7.4 approximately. And the sand silt distribution in the curve, it can be seen that a negative silt versus sand distribution, strong linear negative relation can be seen, and the texture of the soil is dominant with sandy silt with a 53%, then followed by silty sand, which having 42% and 5% of silt. So here in the box whisker plot diagrams, we can observe the concentration of these trace elements in the surface soil, and it can easily be seen that zinc, nickel, copper, cobalt, arsenic, along with chromium, manganese, and lead, these were the major pollutants causing the soil pollution. So these are the spatial distribution maps generated using the ArcGIS, and these are the spatial maps of cobalt, cadmium, and copper. And it can be seen very easily that the elements are concentrated mostly on the northwestern and western areas. A similar pattern can be observed for nickel and zinc, for iron and aluminium also. And but a homologous pattern has been observed for the lead, arsenic, and chromium. It can be seen that chromium and lead are evenly distributed over the entire study area, but arsenic is concentrated only proximate to coal mine areas. And this has been correlated with the wind direction, in which data has been taken from 2000 to 2021, and it can be seen that the major trending direction of the wind is northwest to southeast, with a secondary trend of southwest direction. The figure A indicates the wind direction at a height of 2 meters, where figure B indicates the wind direction at a height of 10 meters. And the box whisker diagram of geoaccumulation index shows that chromium followed by lead are moderately to strongly contaminate. This similar pattern has been followed by enrichment factor and contamination factor, which also shows that chromium and lead are the major pollutants in the study area. But ecological risk factor have shown cadmium followed by lead are the major contaminants, and this might be due to the toxic response factor, which is approximately 30, which has been provided by Hackinson 1980, and that is why it is showing cadmium at a high risk. Then we tried to correlate the elements with the pollution load index, and we have seen that apart from chromium and lead, which have shown some scattered plot as shown in the figure B, and but the zinc and other rest of the elements have shown strong exponential fit, as it can be seen in the Pearson correlation coefficient of heat map, where the deep blue colors are reflect the strong positive correlations, and the red color indicates the deep red color reflect the strong negative correlations. It can be seen with the PLI, the most of the elements apart except from the chromium and lead are moderate to strongly correlated. So let's come to the principal component analysis, where the total cumulative percentage of the total variance is 73.59%, 73.59, and yielded 5 factors. So first factor F1 suggests that cadmium, cobalt, copper, FeMn, nickel, and zinc, these were strongly correlated with each other, and with a moderate correlation with positive moderate correlation with aluminium. Then factor 2 yielded 7%, and factor 3 with chromium and lead, factor 4 PHEC, and factor 5 TOC. This shows that factor 1 is mostly related with the common source, which could be coal mining related activities. F3 is generally shows the chromium correlation between chromium and lead, which is apart from and it has also been seen in the spatial map that they have some analogous homologous behavior, that they were distributed over the entire study area. So apart from the coal mining, there would be some another anthropogenic activities such as traffic emission, weathering of certain overburden rocks, maybe domestic sewage, trash dumping, combustion of coal, and accumulation of solid agricultural waste, irrigation, wastewater associated with irrigation activities. So we can term as a mixed source which is influencing the chromium and lead. F4 and F5 have shown PHEC and TOC. So the association of sand, pH, TEC, and TOC of factors F2, F4, and F5 are and F1 and F3, which are the major dominant part of trace elements, implies that these variables are mostly originating from distinct soil processes or entering the soil from different sources. So the conclusion of the study is that the spatial map showed the analogous behavior of the elements except the chromium and lead, which showed the homologous behavior. Environmental indices showed that chromium followed by lead were the most enriched trace element in the studied soil. Principal components showed that the chromium and lead would be the from common source, where the rest of the element have came from the other sources such as coal mining activities, and they have contributed 37.14% of the total variance as already observed. The findings support that the need for implementation of comprehensive soil monitoring initiatives in close proximity to coal mining regions to isolate pollution hotspots and formulate effective strategies to elevate and prevent environmental detrimental soil contamination. So I would like to thank you, the Director ACSM and CSSM, for my doctoral registration, and I would like to thank the Department of Science and Technology, Government of India, for providing me the DST Inspire Fellowship. I would like to acknowledge the help provided by Dr. Sudeep Maiti and Dr. Hridesh Agarwala for digestion of the samples in the microwave digester, and Dr. Arvind Mesto for the ICP OES analysis of those samples. Thank you.
Thank you, Mr. Prasenjit Chakravarti, for your informative and detailed presentation about trace element contamination soil surroundings in open cast coal mining area in Rajmahal coal field. So that your presentation is really nice, that you have explained it graphically as well as the spatial distribution map. So
Yes,
for
sir.
the different trace elements and toxic elements which is contaminating in around area and mining areas. So
Yes, sir.
yeah, thank you. So
Thanks.
any doubts, please ask Mr. Prasenjit Chakravarti.
Yeah, Prashanjit, very nice presentation.
Thank you, ma'am.
I'm Dr. Tanushree from BIT Mysore. I have
Yes,
just
ma'am.
one question. I just want to know that in your spatial distribution map, how did you choose the scales of the scales are based on concentration, right? So
Yes, ma'am.
what were the scales and how did you choose the scales?
Ma'am, actually, when we input the Excel file into the ArcGIS, so there would be a maximum and minimum concentration, which it automatically detects. And we also used to generate using the Excel sheet where we check the maximum minimum. And on that basis, the ArcGIS it automatically detects that there is a maximum minimum concentration.
Okay.
And yes, ma'am.
So it is unsupervised. No? The classification of scales were unsupervised. The software itself decided the scales, right?
Actually, ma'am, we also correlate it with the Excel sheet, which we see that which is
Yes,
maximum minimum. Yes, ma'am.
Okay. Okay.
Yes, here I will interfere. It is not, I think if I am wrong, just correct Mr. Prasenjit. It's not about unsupervised, it's about cricking method, right?
Yes, sir. It's actually, sir, IDW method.
Okay, okay. Because
Yes, sir.
minimum value it will consider as a least and maximum value it will consider highest. So based on
Yes,
that,
sir.
it's extrapolate. It will extrapolate accordingly, right?
Yes, sir. Yes, sir.
Okay, fine. Okay, thank you, Prasanjit. So anybody
Thank you,
else
sir.
from audience side, any other questions, please?
Maybe I can ask something. How did you estimate the uncertainty of your measurements? And when you make your maps, do you consider the sampling uncertainty? Because I guess because the contamination is caused by this dumping, it must be quite heterogeneous, the distribution of the elements. So this can affect the smoothing surface you see on the map. I don't know if you understand what I say. So have you estimated somehow the sampling uncertainty that you get?
Ma'am, actually, the mining area in the region of the mining area is so much diverse that we cannot follow a particular sampling system. So we have to sample those areas which are accessible via roads or accessible via some field areas, and then we have to collect those samples, and then we have tried to take from a distance of 100 meters to approximately 2 kilometers, so then and in a zigzag pattern, so that we can try to make it suitable and try to remove the uncertainty as much as possible. And then we have does this analysis 3 to 4 times, so that we can check the data and check the standard deviation which come within the plus minus 10 percentage, which came actually plus minus 10 percentage to overcome the error estimation.
Yeah, I understand the analytical part, but about sampling, so have you collected composite samples from a
Yes,
big
ma'am.
area?
Yes, ma'am.
You
Yes, ma'am.
mix soil and you make a composite sample.
Yes, ma'am. Exactly.
Okay. So you increase the sampling support, I guess, in this way.
Yes, yes, ma'am.
Thank you,
Thank you.
Mr. Prasanjit Chakravarti, for your
Yes.
detailed presentation.
Thank you, sir.
Thank you. So next presentation, I would like to call Dr. Tanusuri Bhattacharya. So she's associate professor in Environmental Biotechnology. Department of Civil and Environmental Engineering, Birla Institute of Technology in Jharkhand, in India. So title of her presentation is Assessment of Heavy Metal Contamination in Street Dust, Concentration, Bioaccessibilities, and Human Health Risk and Coal Mine and Thermal Power Plant Complex. So I request Dr. Tanusri to start.
Yeah, the first author, my student, research scholar Mala, will be presenting.
Okay, fine, fine.
My voice is audible?
Yeah, we can able to see your slides.
Yeah.
Please go ahead.
Okay. So, good afternoon. I am Mala Kumari, a research scholar from BIT Mishra. Today, I will be discussing the assessment of heavy metal contamination in street dust, focusing on concentration, bioaccessibility, and human health risk in the proximity of coal mine and thermal power plant area. Next, coming to the introduction part. So as we all know, nowadays, coal has been the primary source of energy for human civilization for centuries. And with the growing population and energy demands, coal mining and thermal power plant have increased significantly. And so because of significant increase in coal mining and thermal power plants, cause significant environmental impacts, including the dust pollution, deforestation, heavy metal pollution, and greenhouse emission. And also it includes the whole air, water, and soil. So heavy metals like arsenic, cadmium, lead are released into the environment, leading to cancer, neurological disorder, and cardiovascular diseases. So coal mining has also been associated with an increase in the incidences of lung cancer, asthma, coal workers' pneumoconiosis, which is also called as black lungs. It's very common in the people who live near the coal mine area. Then silicosis, asbestosis, and other respiratory disease, which is caused by inhaling the coal dust. And how this coal dust or these metals get into our human body is because of three exposure pathways like ingestion, inhalation, and thermal contact, which is shown in the figure. And these metals are also bioaccessible to human bodies. So bioaccessibility study assesses health risk by evaluating total concentration and bioaccessibility of heavy metals. So now we come, this article have basically three objectives, basically to determine the heavy metal concentration in the and pollution indices in the Singrauli mine area, and to assess the human health risk assessment, and to analyze the bioaccessible fraction of heavy metals in the coal mine area. So for methodology, so basically our study area is basically nearby the coal mine area, that is Singrauli, Madhya Pradesh, India. It's come into the latitude of 23 degree 47 to 24 degree 12 minutes north to longitude 81 degree 40 minute to 82 degree 52 east. And it is area covered is 2,202 kilometers square. It is highly mechanized old open cast coal mines. There are many coal mines present there like EGAH, Jen, Bina, etc. And this region is basically have comprehensive environmental pollution index according to 2018 62.59, which is very high. It is high according to the standard of Central Pollution Control Board. So the sampling is done in the winter season. Basically, the street dust is collected nearby the street and taken to the lab. Then the sample is sieved using 63 micron nylon mesh. Then the sample is digested by using the mixture of acids such as nitric acid, hydrogen peroxide, hydrofluoric acid, and sulfuric acid in the ratio of 4:1:3:3. After that, the sample is filtered and analysis in ICP OES. After that, we calculated the metal pollution indices, that is IGO, geoaccumulation index, contamination factor, enrichment factor, and pollution load index according to the standard formula. And after that, the health risk assessment is calculated using the formula given by US EPA agency. For this, we have to calculate many things like chronic daily intake of ingestion, inhalation, and dermal, then hazard quotient and hazard index for non-carcinogenic effect, and CR for the carcinogenic effect. For this, we have to basically input many parameters it is calculated for both adults and children separately by using the average body weight, the skin area, double absorption factors, exposure frequencies, particle emission factors, skin adherence effect, and also the reference dose. These all are need to be considered for calculating this human health risk assessment. Then after that, bioaccessibility is calculated using the in vitro bioaccessibility method. Here we basically what we do, we mimic the condition of our stomach environment experimentally into two phases, gastric and intestinal phases, and with sequential extraction we do the experiments. For first gastric phase, we use the gastric solution, which includes pepsin, trisodium citrate, lactic acid, acetic acid. When we control the maintain the pH of 1.5 of the gastric phase, then we shake the sample at 150 rpm at 37 degrees Celsius. Then after that, we analyze the sample in ICP OES. After this, for the intestinal phase, we should repeat the gastric analysis. Then again, we mix the dust with 0.5 gram of pancreatin and bile salt. Then again, we shake it for 4 hours at 37 degrees Celsius after the analysis of sample in ICP OES. Then for result and discussion, we see the heavy metal concentration in street dust and assessment of pollution indices. Here we can see the metals are there, and its permissible limits are also mentioned according to WHO. And the PLI value, metal concentration, IGO, contamination factor, enrichment factor, all are given. The value which are highlighted in red color is shown that the particular value is surpass the permissible limit, and the value of IGO and CF, which is greater than 1, we can say that the area is polluted, and EF value, which is greater than 5, we can consider that the particular area is polluted. So from the slide, we can see that the metals such as copper, nickel, zinc, chromium, molybdenum, and manganese are high in every location, and we can see that the location near Vindhyachal thermal power plant, the PLI, that is the pollution load index, is very high, 2.34, which is near the vicinity of thermal power plant, is high, and also the metal concentration and IGO EF CF factor is also high in this region as compared to the other regions. And next, you can also see the same trend like the previous one. Here also you can see that the location near Nagar thermal power plant, it is very high, similar to the previous slides. And here also the other location like Anpara, MCL quarter, Bina have the similar trend of result. And here Anpara having the more metal concentration and the IGO, CF and EF. And it is not near the coal mine area, but it is near the close proximity of the marketplaces. Now the major findings of this experiment is heavy metals like copper, nickel, zinc, chromium, cobalt, arsenic, and molybdenum exceeds the background level at all 11 sampling locations in Singrauli, with zinc and chromium about 3 times higher. Here the hotspot areas are highest metal concentration were near thermal power plant at Vindhyachal, Nagar, and Anpara, suggesting the significant impact from these sources. And from the IGO contamination factor, enrichment factor values, the elevated IGO values for cobalt, molybdenum, zinc, and arsenic indicated moderate pollution, while the high contamination factor and enrichment factor values for copper, cobalt, and molybdenum pointed to significant anthropogenic contribution. And for pollution load index, all sample locations in Singrauli had the PLI values greater than 1, indicating pollution. The highest PLI value was observed near Nagar thermal power plant, that is 2.58. Continuing this, the lead concentration in Singrauli were lower as compared to the region like Dhanbad and Delhi, but zinc and chromium level were much higher, while Singrauli pollution load index score were lower than Dhanbad, India, which is 8.22, which is showing very high. And other reason, the area is still heavily polluted with potentially toxic elements. So the hotspot area, the highest metal concentration were near thermal power plant at Vindhyachal, Nagar, and Anpara, suggesting significant impact from these sources. According to global extent, the concentration of metal in Singrauli were higher than in many international coal mining areas, including Canada, Russia, and Poland, highlighting several coal contamination issues. And for the human health risk assessment, after calculating the chronic daily intake, the hazard quotient, then finally I have calculated the hazard index, which I'm showing in this slide. So here also basically the values which is showing greater than 1, we consider that the proper metals is having high health impact to the both children and adults. From the slides, we can see that the chromium and manganese having the non-carcinogenic effect to both the children and adults. And in some places like Vindhyachal, the children also have an impact of the metals iron. The similar findings is also here in the other locations. Both adult and children are having non-carcinogenic effect because of chromium and manganese. For the carcinogenic effect, here the values which is scored greater than 1 into 10 to the power minus 5 is considered that the particular metals having considerable carcinogenic effect to the humans, both children and adults. From the slides, we can see that the exposure pathway, inhalation only causes the carcinogenic effect, also only in children, not in adults. Only few cases adults are also showing the effect. Here also same findings are available for other location. Only the nickel and chromium having carcinogenic effect on the exposure pathway of inhalation in children, and few location having adults also get affected by these metals. So the major findings is exposure pathway according to children are more vulnerable to non-carcinogenic health risk from dust ingestion, inhalation, and skin contact. Adults higher chances of heavy metal ingestion due to faster food consumption rate. For non-carcinogenic risk, children have higher risk from chromium and manganese ingestion and iron through dermal contact. Hazard index value which scored less than 1 for all the trace elements except chromium and manganese in children and adults. Iron in children near specific location, example near Vindhyachal thermal power plant and Antara. Minimal risk from dermal absorption for both children and adults. Major findings are from carcinogenic risk. Children have higher carcinogenic risk. Copper and nickel pose carcinogenic risk primarily through the inhalation. Comparative findings, we can see that the consistency with finding in other coal mining areas, example, Northern and Hui province, China, and Dhanbad, India. Similar non-carcinogenic risk pattern observed in studies from West Bengal and China. For the bioaccessibility and heavy metals, these are my results. The values which scores greater, or the fraction which scores greater than 20%, we can say that that particular metal is particularly more bioaccessible to human body and can cause problem in the gastric or intestinal phase. So here from the slide, we can see that some metals like arsenic, cobalt, nickel, lead, and zinc are bioaccessible to human body. And we can also see that the metals are more bioaccessible in gastric phases as compared to the intestinal phase. Here the lead is also bioaccessible in the EGAH region. So for the bioaccessibility, the major findings is the key metals showing high bioaccessibility in the gastric phase includes zinc, lead, and manganese. Some environmental factors include factors such as industrial activities, traffic volume, and physiochemical properties like pH, electrical conductivity, and organic matter impact metal bioaccessibility to the human body. High bioaccessibility near industrial area suggests increased contamination from activities like coal mining and thermal power plants. So metals in the vicinity of thermal power plant and coal mine areas such as near Vindhyachal and Shaktinagar are more bioaccessible. In residential area, lower bioaccessibility may be attributed to natural filtering activities such as gardening or afforestation. Copper showed notable higher bioaccessibility in the intestinal phase at certain location like Jayant Morva, it is showing 6.53% and Amlori in 17.70%. For statistical analysis, this is statistical analysis. I have done the correlation with each metals. First one is chromium. It is shown that each metals and each all the total metals is with all parameters is correlated with each other. We cannot find that the chromium is bioaccessible to human body. That's why bioaccessibility is not included in this graph. The second one is of nickel. Here we can see that there is positive correlation between bioaccessibility in gastric and intestinal phase, which is highlighted here. That is 0.93. That is 0.93. And for lead, all the parameters are positively correlated with the total metal concentration. Next, for arsenic, there is no such formulas is there for health risk assessment for both carcinogenic and non-carcinogenic. That's why that parameter is not added in this correlation plot. So here also there is positive correlation between the gastric phase and the intestinal phase. Next, the cobalt is also having very good correlation between the gastric and intestinal phase. And vanadium doesn't show any correlation with any of such parameters. For hair also, we can see that hair show that 0.57 correlation is seen between gastric and intestinal phase. And for zinc and copper, there is no positive correlation is observed in this slide. Correlation major findings for bioaccessibility of metals was generally higher in the gastric phase than the intestinal phase due to the lower pH in the gastric phase. Strong positive correlation between gastric and intestinal bioaccessibility for copper, nickel, cobalt, arsenic, and neman is observed. For health risk, high correlation between non-carcinogenic risk for both adults and children with metals such as copper, lead, chromium, iron, zinc, and manganese. Carcinogenic risk for chromium, lead, and nickel were strongly correlated with total metal concentration and exposure route. Here, the R square is equals to 1 for ingestion and inhalation and 0.98 for dermal exposure. For the conclusion, I say that the high metal concentration, the highest near the thermal power plants, exceed permissible limit for manganese, chromium, arsenic, copper, and zinc in street dust. Health risk, according to health risk, children are more vulnerable to non-carcinogenic risk from road dust. Children likely to inhale heavy metals, adults more likely to ingest them. No significant non-carcinogenic risk observed for both adults and children. For bioaccessibility, higher bioaccessible metals are cobalt, copper, nickel, lead, and zinc near the thermal power plants. And for implication, we say that the heavy metal concentration exceeds regulatory limits due to extensive coal mining and industrial activities. Significant health risks posed by heavy metals, including carcinogenic and non-carcinogenic effects. Need for further research on heavy metals bioaccessibility in Indian coal mine areas. For recommendation, we can say that urgent need for addressing health hazards from mining and power generation industries, and to support for comprehensive remediation measures and continued scientific inquiry. So basically, this research is crucial because it quantifies the elevated level of heavy metals in street dust in Singrauli, India, revealing the significant health risks and bioaccessibility, particularly for children and underscores the urgent needs for effective mitigation strategies and further studies for bioaccessible metal fraction in coal mining region is much required nowadays. So these are my references. Thank you.
Thank you, Dr. Tanusuri Bhattacharya and her research scholar, Mala Kumari, for detailed presentation about heavy metal contamination and concentration near the coal mining and thermal power plant areas. So if a audience have any questions, please ask her.
I would like to ask a question.
Yeah,
Mala, congratulations. A really good work. Was it you in the photograph sampling?
Yeah, yes, ma'am.
Good. Can I ask you, do you have an idea from your study about the chromium speciation? You talked about total chromium, but do you have an idea of the fractionation and the chromium 6 levels? And also, if you have not done a speciation study, does the model that you used for the health risk has an assumption about this?
This model is used, it is basically a standard model which is given by US EPA. That is only we have used and calculated. And for the speciation of chromium, we are planning to do the isotope studies if it is possible. Then we basically further we do those things.
But does the model assumes that a certain fraction of the total chromium is hexavalent chromium? Maybe we can check the model. Thank you very much. Congratulations.
I'd like to answer a question. The model doesn't assume that chromium is chromium 6. But yes, the model takes the value of total chromium only.
Okay.
Thank you. Thank you. Anybody else? Anybody from audience side? Any other questions? Okay, thank you. Thank you. So next presentation, I would like to call Mr. Siddharth. So in place of Sankamitra Pradhan, and Mr. Siddharth Pradhan going to present. So his topic is integrative study of Permian coal bearing horizons, biostratigraphy, paleovegetation, and paleoclimate in the South Karanpura coalfield basin. So now I request Mr. Siddharth to start presentation.
Hello. Very good afternoon to all of you. Am I audible and am I
Yes,
visible
yes,
to all of you?
yes,
Yep.
yes.
Okay. May I close my video to start the PowerPoint
Yeah,
presentation?
go ahead.
Okay. Thank you, sir. So, good afternoon to all of you. I am Siddharth Pradhan, and thank you so much for working. Sir, is my screen is visible to you?
No, please share your presentation, please.
Okay. Sir,
Yeah, make it presentation mode. Yeah, go ahead. Siddharth, unmuted.
Yes,
Seems to be muted. Yeah, unmuted it and start presentation.
sir, am I audible now?
Yeah, now we can able to hear you. Continue.
Okay, sir. Okay, sir. Good afternoon to all of you, and thank you so much for inviting me to present this topic before you. Actually, I am Siddharth Pradhan. I have completed my MSc Tech in Applied Geology from IIT ISM Dhanbad, and today I am presenting. Today I am going to present you the topic named Integrative Study of Permian Coal Bearing Horizons, Biostratigraphy, Paleovegetation, and Paleoclimate in the South Karanpura Basin. And the paper is authored by Dr. Sangamitra Pradhan and co-authored by Dr. Sirup Goswami sir, Dr. Neha Agarwal ma'am, and Dr. Runsi Paul Matthews sir, Dr. MC Manoj sir, Dr. S. Surai K. Pillai sir, and myself. And before starting, and I have a person of interest here too. I would like to thank Dr. Runsi Paul Matthews sir, who has been my guide during my internship days in MSc Tech during my MSc career, and who has been also a co-author of this paper. Thank you so much, sir. So before starting, integrated and comprehensive study of the coal bearing horizons from South Karanpura basin is to delineate the biostratigraphy, paleovegetation, paleodepositional setting, and paleoclimate in and around the investigated area during the deposition of Permian sediments. South Karanpura coalfield is one of the major coalfields of Jharkhand, India. It occupies the western part of the Damodar basin and forms a narrow, elongated sub-basin. I have the photo in the next slide, actually. It spreads above an area of 194 square kilometer and lies between the latitude 23 degree 30 minute to 23 degree 45 minute and longitude of 85 degree 05 minute to 85 degree 28 minute in the Hazaribagh district of Jharkhand. And here Gondwana sediments is well deposited and exposed to in the South Karanpura basin, yielding the idiosyncratic plants, megafossil and paleonomorphs. So here we have added the geological map of the South Karanpura basin, which has been zoomed to the location of investigated fossil locality. Okay, here the table represents the stratigraphic succession of the South Karanpura basin, Jharkhand. Here we can see that Raniganj formation itself is the hoping 610 meter thickness, and the Talcher formation has barely 3 to 16 meter thickness. And if we focus on the time period of the study area, it belongs to the Permian, and the epoch is the Silurian to Lopingian epoch. And here we have presented the stratigraphic correlation between different Gondwana sedimentary basins of India during Permian, showing the corresponding formations and relative ages too. So here it is the semantic stratigraphic succession of the study area, which presents the different fossiliferous horizons and floral assemblies. Here the index are mentioned in the diagram too. Here the something mentioned that RG1, RG2, RG3 up to RG8. Actually, these are the different. These are the these are discrete litho units actually. And as we can see here, the index is presented here. The RG2 to RG4 comes under the lower Permian, and the RG4 to RG8 comes under upper Permian, where RG2 has the lower Barakar formation, has megaphoral assemblies 1, and the RG3 to RG4 has the upper Barakar, and it has megaphoral assemblies 1 with it Palena assemblies 1 too. RG4 to RG8, it is upper Permian and Raniganj formation with megaphoral assemblies 3 and Palena assemblies 2. Yes, so here we come. The objectives of the topic is the demarcation of the fossiliferous horizon to study the macro and microflora assemblies from different Gondwana formation to investigated area to study their botanical affinity and to depict the paleovegetation and paleodiversity in the studied area. Second one is the delineation of the geological setting of the fossil-bearing localities and establishment of the biostratigraphy of these horizons to mark their stratigraphic position in the Indian Gondwana sections and to correlate it with the other paleogenetic basins of India based on the macro and microfloral evidence. To undertake the third one is to undertake the morphotaxonomical studies of the plant fossils recovered from the different formation of these basins and the comparison with the known floras of other coalfields or basins of the Indian Gondwana to reveal paleoecology, paleodiversity, paleovegetation, and the paleoclimate of the investigated area. To study the Palena assemblage, where the Palenomorphs means the spores and pollen, etc., recovered from the respective sediments and their comparison with the known Palenomorphs of other Indian Gondwana basins to depict the age of the sediments, exact stratigraphic horizon, paleoclimate, and their botanical affinities actually. And fifth one is to investigate biomarkers, which is N-alkanes, and measure element concentration from the studied sediment of South Karampura coalfield to determine the source vegetation and provenance of the paleo depositional composition. Before that, I want to, before telling the methodology, I want to tell that. And the study actually deals with the integrated and comprehensive study of the coal bearing horizons from South Karampura basin actually to totally to delineate the biostratigraphy, paleovegetation, paleodepositional settings, and paleoclimate in and around the investigated area during the deposition of Permian sediments. Okay, we came across actually highly diversified megaphora assemblies, which consist of 13 genera and 72 species of order Glossopteridales and Corditales and Equicetals, which are documented among which 37 taxa are newly reported from Barakar and Raniganj formation of the area actually. So actually here we have done, wait a minute, sorry. So current study actually portrays that Permian climate was cooler in initial phase, which we have found in. I will show you in the later PPT. So actually this total topic is the first integrated approach that cumulates different proxies. We have actually 4 proxies here. One proxies is megafossil. Second proxies is palynology. Third proxies is the organic geochemistry. I mean the biomarker study, and the fourth one is the inorganic geochemistry study. I mean through the XRF actually, and through these different proxies, tools and their significance to decipher paleovegetation, paleoecology, paleoclimate, and depositional environment. And all these studied samples have been collected from the Religara colliery actually. So here comes the methodology. The work has been basically divided into two parts actually. Field work and lab work actually. In the field work, samples are collected from the different coal bearing horizons of freshly exposed quarries of the collieries for the paleobiological investigations. Sampling of carbonaceous cells, sandstone, coalescence, and coal has been done in pillar sampling method and tagged separately to avoid contamination for geochemical studies. In the laboratory work, which have been done in BSIP2, collected samples of the carbonaceous cell or analyzed fossil occurrences. The carbonaceous cell, sandstone, coalescence, and coal samples were macerated to extract the polynomers by the traditional maceration techniques. The optical slides of the samples were prepared for the polynomial investigations. The productive slides were scanned under the optical microscope and photographed meticulously. The organic geochemical studies, the sample were crushed by using the agate pestle and the mortar. The powder was also extracted by the ball mill to get very fine size powder suitable for inorganic geochemical analysis. So here we come. For the Megaphora morphotaxonomy, we have done three things. First, the removal of superficial layers, and then observation and identification of specimens, and then its photography. And for palynological study, we go through first maceration, then we treat it with HNO3 nitric acid with 63.01% volume by volume. Then actually it is not KOH. There is a problem. There is a mistake here. It is not KOH. It is actually hydrofluoric acid with 40% concentration, and then sieving and slide preparation and photography. Here, actually, the hydrofluoric acid is used. Hydrofluoric acid is it is called hydrofluoric treatment actually, which is used for the removal of silica. I mean, the hydrofluoric acid removes the silica actually, and organic matter is removed by the nitric acid actually. Then the organic geochemical analysis, which is called biomarkers. Biomarker analysis of the 6 samples we have taken. It is RG1, RG2, RG4, RG7, and RG8. Has been performed in the study. Analysis of only saturate fractions are discussed. The procedure started with the extraction of soluble organic content, in which DCM dichloromethane is to methanol, which 9:1 ratio mixture was added to the over-dried samples and ultrasonicated for 30 minutes. Afterward, the precipitation and removal of asphaltenes was carried out by adding an excess of N-hexane 40 ml to the samples. The recent study focused on the saturated fractions only. The saturated compounds were extracted by column chromatography method, in which N-hexane was added to the asphaltene-free extract and was passed through a chromatographic column containing activated silica gel. The analysis was carried out using the Agilent 7890A gas chromatography GCMS interface with the Agilent 5975C mass spectrometer. And the ChemStation software is used for the data processing. Peak assignment were based on the GC retention time and mass spectral data, including a comparison to the MS library and published mass spectra. For the inorganic geochemical analysis, the samples were collected for freshly exposed coal, coalescence, carbonaceous cell, and sandstone horizon in pillar sampling method. Samples were wrapped and packed separately to avoid contamination. The samples were actually RG1, RG2, RG4, RG5, RG7, and RG8, both for biomarker study and inorganic study. We have considered these litho units. Before the XRF analysis, crushing of the sample were carried out with the help of a planetary ball mill, followed by the homogenization by coning and puttering method to obtain 200 messages of the ASTM standard. Then the pressed pellets were prepared for the major element analysis using boric acid as a binder. Further, the semi-quantitative analysis of a samples was performed using Omnium standardless analysis software. For loss of ignition, the samples were heated at 1000 degrees Celsius for 2 hours, and the wet loss was measured. The major element concentration were obtained during wavelength dispersive X-ray fluorescence spectroscopy, that is WDSRF model, pan-analytical, Exomax, and 4 kilowatt. So here the results are for the megafloristics. 3 distinct megafloral assemblies, 1, 2, 3 actually have been retrieved from the lowermost coalescent horizon, that is RG2, middle horizon of the carbonaceous cell RG4, and the upper carbonaceous cell unit RG5 respectively. One for actually RG2, megafloral assemblies 2 for RG4, and megafloral assemblies 3 for RG5. Here its litho units are actually which symbolizes the results are. So altogether 1308 specimens of 72 species have been congregated. So though the assemblies comprise of 2 plant group actually, pteridophytes and gymnosperm, which include 3 orders, chordales, equisetials, and glossopteridals, and 13 genera along with stem cast and equisetaceous stem. The recovered order glossopteridals consist of imprints of leaf, scale leaf, and root forms, that is Glossopteris, Gangamopteris, Dencania, Glossotheca, Partha, Eretmonia, Skyroma, and Besustobros, and Vertebraria. Equisetials order consist of Cyzoniura gondwanensis along with the equisetaceous stem, and order chordales contains imprints of actually Noigraphthyosis hislopi, Noigraphthyosis minor, and Euriphyllum hoytenium. The studied area is signified by a wide diversity of Glossopteris species, which includes which includes 54 taxa actually. So this is the lithosuccession of Religara collier, which represents the assemblies. Here the Palina assemblies will be mentioned in the next slide actually. So this is the different plant groups from Religara megafloral assemblies, which I just told you. So for the Palinoflora, 2 discrete Palinoflora assemblies 1 and 2 have been retrieved. RG3 and RG4, here it is mentioned, which possess the Palino assemblies 1. RG3 is marked by the abundance of straight bicycles, faunipollinates, 37.5%, and striatopodocarpides, 25%, and the subdominance of non-straight bicycles, 20%, and Ipsporites, Diplosuchus, 12.5%. Other recorded taxa of these Palina assemblies are Beribulates communis, 0.5%, Paracycates plicatus and Paracycatus distinctus, 1.5%, Plicatipollonites, 0.5%, Hemiapollonites species, 0.5%, and Striatites communis, 0.5%, and Lunatitis sporonites pellucidus, 1.5%. So Palina assemblies 2 is reported from the upper units of the litho column, that is RG5 and RG7. RG5 is marked by the governance of straight bicycles, which is Striatopodocarpides, 32.5%, and Hemiopollonites insolitus, Hemiopollonite bifurcatus, 16%, Faunipollonites, 15%, along with some stratigraphically significant strata. Stoterosporites ovatus, 2.5%, and Crescentipollonites globusus, 1.5%, Lunatitis sporites pellucidus, 2.5%, Clausipollonites, 1%, Falcisporites zappi, 1%. Sorry, 1%. Cordra sporite, 0.5%. Wellenites, Lucifer, 0.5%, and Campsicsacides campsiensis, 0.5%. So this is the histogram, which shows the quantitative distribution of the Palino taxa from RG3 to RG5, which represents Palino assemblies of 1 and 2, respectively from the Religara Curiae. These are the plates which we have found from the Religara Curiae for the Palino assemblies 1. This is plate 2 for the Palino assemblies 2 of the Religara Curiae. So here we are. Organic geochemical analysis or biomarkers. The biomarker signature obtained from the samples are more or less similar. You can see here. The processed aliphatic hydrocarbons include normal alkanes and acyclic isoprenoids, that is pristine and phytane. It comes on pristine comes under C17. After that, pristine comes. The aliphatic compounds are dominated by normal alkanes ranging from C14 to C29 alkane. A unimodal pattern of an alkane distribution is dominated in the sample, as you can see here, set with a very long chain input, C27 to C29. RG1 sample has C max at NC3, and where the RG2 sample has a higher abundance of NC19 and C23. RG4, RG5, and RG8 have maximum abundance at NC18, while RG7 shows the dominance of NC18 and NC19. The pristine predominance over phytane in the bottom sample, RG1 and RG2, and vice versa can be seen in the rest of the sample. RG4, RG5, RG7, and RG8. Pristine phytane values ranges from 0.65 to 6.56. The total distribution pattern, as we can see here, is the unimodal in nature. Here, this is the inorganic geochemical analysis, as we find from the XRA. And we also we also calculated some ratios like CIA, CIW, ICB. These are the ratios to demarcate paleo environment situation, and actually it is more related to weathering. The weathering, it shows the intensity of weathering actually. CIA and CIW, CIA and ICB are mostly opposite to each other, where the CIA will be higher and their ICB will be lowermost. So discussion and conclusion, floral affinity and biostratigraphic correlation for the megaloflora, highly diversified gymnosperm order glossopteridals, and some of the pteridophytes with clans of stem cast and equisetaceous stem are retrieved from 3 different fossiliferous horizons of polycell and carbonaceous cell layers of Religara curiae. 1 codintolon species, that is Noegraphtiosis minor, and 27 glossopteris species, as mentioned here, are newly reported from the studied area. The whole floral assemblage is dominated by the genus Glossopteris, occupying nearly 80.69% of the total assemblage, where Glossopteris communis is 13.16%. G. tenuifolia is 8.49%. Glossopteris indica is 7.34%. Glossopteris tenuinervis 6.5%, which predominates over rest of the collection. The lowermost floral zone, that is assemblage 1, is retrieved from the 0.8 thick polycell horizon RG2, lying over Argada coal horizon of upper seam A, which is lithostratigraphic assigned to the Barakar formation after Rajarao 1978. The occurrence of 20 narrow mesh form species and 3 medium mesh form species of Glossopteris, with existence of typical Karaharbari flora, that is 3 non-reticulate plant species, that is Euryphylum huitanum, Noegraphtiosis hislopi, and Noegraphtiosis minor, and 2 mid-rivals reticulate species, that is Gangamoteris augustifolia and Gangamoteris major, demonstrate the sediments belong to the lower Barakar formation of late Atkinsian age, after Singh et al. And Goswami et al. 2018. 31 Glossopteris species dominate over the floral assemblage 2, which are collected from 0.6 thick fine-grained carbonaceous cell unit, that is RG4 of the lithochrome. Most of the Glossopteris species are of intermediate mesh form, or like assemblage 1. Typical Karaharbari flora are not reported in this horizon. Thus, the sediment is supposed to belong to the upper Barakar formation of Congregrian age, and this assemblage also include Glossopteris root species, that is Vertebraria indica, and 9 genera of Glossopteris scale leaves. The uppermost floral zone, that is assemblage 3, reported from the 3rd most carbonaceous cell horizon RG5, with a thickness of 0.8 meter, comprehends 1 equisetalan taxa, Cyzoneura gondwanensis with some equisetan stem, and 11 petiole, medium to broad mesh Glossopteris species, with complete absence of the archetypical triassic flora, that is Dicrodium flora. This floral assembly is confined to the uppermost fossiliferous horizon, that is assigned to the Odian Changxijian age of Raniganj formation. In discussion of palinoflora, 2 palino assemblies 1 and 2 are congregated from the present collection. As Palino assemblies 1 reported from the Kohli cell, Palino assemblies 1 means we are talking about here upper Varakat, upper megafloral, where we also found megafloral assemblies 2. Yes, it is also that it is predominated by the occurrence of the straight bicycles, pollinites of and striatopodocarpites, and subdominated by non-straight bicycles, Seasonaringi pollinites, and evisporites diplosuchus directly. So its resemblance with the Palinoflora of the upper Varakat formation of the congruent age. The Palino assemblage 2 is done by the dominance of striatopodocarpites 32.5%, hemiopollinites 16%, faunipollinites 15%, along with some stratigraphically significant taxa. And this is stratigraphically significant for the upper Permian period and denotes its resemblance with the Raniganj Palinoflora of the Raniganj formation, which is of Vodian Transition age. So here all of the Palinotaxa which we have found in the assemblies 1 and assemblies 2. As we can see, the Paeonipollinites is in assemblies 1 is 37.5%, and in assemblies 2 it is 15%. Hemiopollinites, we have not found any hemiopollinites in assemblies 1 actually, but it is in 16% in the assemblies 2. So, and Seoringi pollinites in the assemblies 1 is 20%, where it is absent in assemblies 2. And Striatopodocarpites is in assemblies 1 is 25%, and it is found also in the assemblies 2, but it is dominated in assemblies 2 with 32.5%. So in paleovegetation and paleoecology during Barakar, late Artesian and Congrian age, the assemblies suggest that wide diversity and maximum proliferation of megaflora in Religara foliori. The profusion of Barakar coal reserve among Gondwana coal majors clearly indicate that the existence of dense forest associated with the swampy or low-lying river area, which provided conducive condition for coal formation. Here we are talking we are talking about the lower Barakar actually. Yes, and the recovered Barakar floral assemblies have prolific glossopteris floral elements, and with the presence of coriatals, which indicates luxuriant green vegetation. Massive green vegetation of arborescent trees with small herbs and shrubs growing beneath the large trees. Hundreds of specimens of detached and dispersed glossopteris flora recovered from the sediment of different layers in a small area represent the deciduous nature of glossopteris, indicating annual leaf fall. The gymnosperm like Euryphyllum, Neugrathiosis, Gongamoteris and Glossopteris, along with some conifers, were supposed to form a terrestrial ecosystem that could have been the provided organic detritus for peat formation. The retrieved megafloral assemblies do not comprise with any filicates, but can be taken into consider as forms, namely Neomyriopteris and Sphenopteris, were previously reported by Kulkarni and Maithi from the studied area, hence the marshy ecosystem it is. The comparative drops in stream velocity, riverbed depth, and width, meander wavelength, annual discharge, and clash flow velocity during the Barakar might have provided advantageous marsh forming environment alongside the low-lying rivers. Palino assemblies 1 decipher a lush green arborescent vegetation in which glossopteridals having more than 95.5% evidence remains the prime contributor of the terrestrial land plants, along with the coniferals, which is merely 2.5%. Although coriatals 2% and filicals have 0.5% contributed to a minor extent in this assemblies. And this significant taxa depict the presence of a wetland near the depositional site. The lack of marine signature in the sediment depict the proximal freshwater forest form and their concurrence with terrestrial landmass. So during Raniganj also, the recent study divulged the predominance of large leaves with the wide midribs and apparently broad mass Glossopteris over the present collection. The incidence of equicetals, that is Hygienera gondwanensis, depict towards the existence of terrestrial water bodies in the form of ponds or lakes, which signify the prevalence of marshy ecosystem. The dominance of saccade gymnosperm of glossopteridals with subdominance of coniferals and coriatals. The percentages are mentioned here in upper Palino assemblies, that is assemblies 2, are indicative of terrestrial ecosystem, while the presence of Helicopsids and Peltaspermals suggest marshy ecosystem. So for paleoclimate, during Baraka, the existence of typical Carrarbari plant fossils, that is Gongauteris, Noegrathiosis, and Euryphylum in lower Baraka formation depicts comparatively cooler climatic condition sustained over the late Archean times. Narrow mesh forms Glossopteris with broad front, spatulate to oblancoilate shape and mostly obtuse apices depicts the inadequacy of the sunlight. Due to there is inadequacy of sunlight, so their shape enlarged, they get enlarged in nature. Their, I mean, the mesh actually get enlarged so to receive maximum amount of sunlight. The dominance of sessile leaves indicate calm wind condition. The notable changes in floral habits signified by medium mesh leaves of medium to large size, lanceolate shape, acute apices, and acute cunate bases with entire margins during congregation delineates the onset moderately warm condition with the high humidity. Availability of sufficient sunlight resulted into the emergence of acute apices and acute cunate bases. Other leaves did not have to expand their front to absorb more sunlight for photosynthesis. The polynossemblage of the congregation age is governed by glossopterids and scarce of occurrence of podicles, coniferals, and filicles. Advocate a moderately warm and humid climate over the congregation age, which turn out to be conducive coal forming environment. The presence of carbonaceous phases and the dominance of broad mesh leaves with thick midrib, acute apices, and acute cunate bases indicate relatively warmer and high humid climate with intermittent rainfall during Odian and Changsijian times, which provided a favorable condition for luxuriant growth of the upper Permian flora. The vegetation was lush-green dense but sparse with comparison to the Baraka. This might be the reason behind the absence of coal seams in the studied area. The presence of petiolate glossopteris specifies high wind velocities during Odian and Changsijian times. The predominance of saccate gymnosperm or pollen grains over spores in upper pollinous assemblage, that is assemblage 2, indicates the temperate climatic condition. Governance of glossopteris that is greater than 60%, followed by the coniferals and podicles, along with some few peltaspermals, which suggest that an overall warmer and high humid climate condition with seasonal dry spells during the deposition of this sediment. The rubidium strontium ratio and the strontium copper ratio ranges from the 0.28 to 2.67 and the 0.88 to 1.98 respectively, which implies a warm humid climatic condition for late Archean and Changsijian times. The L2O3 TiO2 ratio is used to climate indicator of the source area. Less than 20 in humid condition, where greater than 30 is in arid climatic condition. The average L2O3 to TiO2 ratio of the Religara coriae sequence is 16.25, which indicates the humid to semi-humid climate actually. So here the GCMS, what we have found from the GCMS spectrography, the depositional environment based on the molecular fossil signature, that is biomarker. The unimodal distribution pattern in the sample appears to be the like measure input from the single source of organic matter. The abundance of odd chain alkanes ranging from C16 to C24 in polycell, that is RG2 sample shows the involvement of microbial activity in the basin. The absence of long chain N-alkanes, that is C27 to C31, is absent here in uppermost sandstone horizon, that is RG8, which suggests a lack of higher plant input. The contribution of algae is identified from the C17 to C19 occurrence. The high abundance of C18 is shown by carbonaceous cell and sandstone sample, that is RG4, RG5, RG7, and RG8, which indicates increased microbial activity. An increase in algal input can be depicted from the high evidence of C19 in the upper cell horizon. The evidence of mid-chain N-alkanes suggests that input from the aquatic sources, comparatively moderate to high water level condition, was prevalent in the area during the formation of coal, as input from the elevated C25, as C25 is higher there. A low abundance of C27 is encountered in cell as microbial organic matter dominates the higher plant input. the low abundance of C27 in low coal samples could be due to the result of the high thermal maturity. This is also supported by the universal distribution of higher abundance of mid-chain alkyls, which is usually encountered in the mature coals due to obliteration of organic compounds with higher thermal maturity. The Christian-Phyton ratio is greater than 3 in coal, that is Rg1, and coal-cell Rg2 sample respectively deduce oxic basin condition during the deposition. And the Christian-Phyton ratio less than 0.8 is suggestive of an anoxic basin condition and can be seen in Rg7 and Rg8 sample. It is mentioned here. As suboxic to anoxic depositional condition is informed from the cell samples Rg4 and Rg5, which is Christian-Phyton ratio must be within 1 to 0.8. So here is the table which shows the which we have calculated the depositional environment from the Christian-Phyton ratio actually. So in paleoweathering and provenance study, only the sandstone has higher SiO2 value than the average upper continental crust. It has 58.38%. It indicates the SiO2 investment actually. Coal and carbonaceous cell have relatively lower SiO2, that is 23.95 to 44.47%, which indicates depletion of SiO2 in this sample relative to the upper continental crust. The higher L2O3 content in the sediment indicates enrichment values because of the dilution effect of quartz. The L2O3 content of shale and sandstone is higher than that of coal. TiO2 values also indicate enrichment throughout the sample. Here we have calculated the CIA, which is chemical alteration index, PIA, WIP, and CIW and ICB. CIA indicates the intensity of suggests the intensity of chemical weathering. So actually CIA actually reflects the degree of aluminum silicate minerals, especially feldspar weather to the clay minerals. The higher the CIA value, it indicates the stronger chemical weathering and more leaching of sodium and potassium and calcium bound minerals from the parent rocks. So the Relicera colliery has a very high CIA value, which indicates the area has experienced intense chemical weathering, where lower ICB values, as I mentioned earlier, CIA and ICB acts opposite. I mean, if the CIA value will be higher, the ICB value will be low. So high ICB value actually indicates the compositionally immature source rock rich in non-clay silicate minerals, where low value represent the compositionally mature source rock. The Relicera colliery seconds has a very high CI value, which indicates that the area has experienced intense chemical weathering, and the lower ICB value indicates that highly mature clay type rocks were associated with abundant clay mineral kaolinite. The L2O3 Na2 ratio in the sediment are generally low, 1.47 to 5.84, which indicates moderate to high weathering intensity and are consistent with the CIA value. The CiO2 and CiO2-LTO3 ratio is used to determine the sediment. Its textural maturity with a high value greater than 10, indicating high recycling and sediment maturity. The SiO2 and L2O3 values from the present study indicate that the studied sample have a very low compositional maturity. The L2O3 TiO2 ratios as well as ICB and CIA values versus CIA value suggested that the intermediate rocks could be possible, could be the source rock for the Relicera colliery sequences. The P2O5 L2O3 ratio from the Relicera colliery formation, it depicts that the prevalence of continental freshwater environment during the deposition of sediment. It suggests that the phosphorus content in the Relicera colliery is inherited from the hydrosilizate fractions of the weathered products, and no phosphorus was absorbed by the sediments due to low phosphorus value of freshwater. So here the chromium nickel and nickel copper and nickel cobalt ratios are also used to determine the depositional environment of the basins. The average ratios in the Relicera samples of chromium nickel is 1.14 and nickel copper is 146. It is 1.46, wrongly mentioned. Nickel cobalt is 1.69 respectively, and which indicates oxic to disoxic condition during the Religara sediment deposition. This is mentioned here, which show that warm, humid climate. So due to the destruction of plagioclase feldspar and the weathering, removal of sodium and calcium, the early stages of weathering exhibits trend parallel to the ACNK line. This is as the sodium and calcium get removed and K2 is get preserved, it gets a parallel to the L2O3 and CaONA2O line. That CaONA2O is getting depleted. The weathering process then destroys the K feldspar, releasing K and shifted to the residual composition towards L2O3. All the samples, sorry, I wrongly mentioned, the weathering trend will be upward. From this, it will weather to this side. Okay, the weathering process then destroys the K feldspar, releasing K and shifting the residual composition toward the L2O3. All the samples in this study fall near the L2O3 K2O joint, indicating a high to severe weathering condition in the source area. Thank you, sir. Hello.
Thank you, Mr. Siddharth, for detailed
Yes,
presentation using different proxies like biostratigraphy, paleovegetation, and paleoclimate of south current flow coalfield.
Yes, sir.
Thank you. So I would like to ask the audience if there is any questions. So please ask Mr. Siddharth. Seems to be there is no questions from audience side. So
Okay,
we are almost completed all the presentations. So it starts with Mr.
Thank you,
Dr.
sir.
Santosh, how to utilize biocomposite panel. So using coal and biomass blending. So next to Dr. Saswati. So yes, she has explained about RE exploration and coal gasification of suitability of Rajmahal coal field. Then Dr. Ansipal Matthew, he has explained about marine inclusion and deposition environment of Rajagara coalfield. Then Prasenjit Chakravarti, trace element contamination in soil surrounding open cast mining and Rani coalfield. And Dr. Lal Singh is traveling actually as some network problem, so he's not able to present properly. So then after that, Dr. Tanusri and her student, research scholar, heavy metal contamination in coal mining areas and thermal power station. So then last presentation, the detailed presentation about Mr. Siddharth, integrated study of Permian coal bearing horizon using different proxies like biostratigraphy, paleovegetation, and paleoclimate in South Karanpura coal field. So I thank all the authors for those who have contributed in this special issue. So once again, I thank all of you. So now I'm giving to Professor Ariana, President, Society for Environmental Geochemistry and Health, for concluding remarks.
Thank you all very much for being here today. It was really, really interesting. It is just a small sample of the collection of 27 papers. So we had the opportunity to see examples. It's a wide range of topics, really, but with the common central topic of coal mining and utilization and the effects on the environment. Congratulations to all. And I hope that this today's session will reach a wider audience when we will put it on the YouTube of the SEGHs. Of course, I welcome you all to SEGHs, be part of it, be members of our community. We would like to see India getting more into our community. And you are mostly welcome. And I hope that we meet in the future, even in a live event. Thank you very, very much.
Thank you, Professor.
Thank you, ma'am.
Thank you, everyone.
Thank you, sir. Thank you, ma'am.
Bye.
Thank you, sir.
Thank you, Dr. Gobi, and thank you, Adriana.
Thank you.